Okay, so here we go with the rational zeros, section 5.6. This first video I'm going to walk through really the big idea of section 5.6. So you're going to be given all sorts of different polynomial functions and you're going to be asked to find the rational zeros. You're also eventually going to be asked to find every single zero, whether they're rational, irrational, imaginary, real. So we'll kind of tie it all together. So here you go with your first theorem. And I really, I don't think that you need to write this down. I think just listen to this slide and you decide how to, best make sense. But the rational zero theorem says if you have any polynomial function, okay, so this right here is just a polynomial. You don't have to write down all of that notation necessarily. And let's say that it should all have real coefficients. Okay, so you're not going to have like imaginary pieces in this function. The rational zero theorem says that possible rational roots, and I would probably write down this, actually. Write down this. Don't even worry about the P and the Q necessarily. So the rational root theorem says to take all the factors of the constant term, okay, so that's the number at the end of your polynomial with no x, and divide it by all the factors of the leading coefficient, so that's the number in front of your degree, and plus or minus all of those are possible rational zeros. Okay, now what's really important about this theorem is it's only possible rational zeros. That doesn't mean that any of them work. That doesn't, or it might mean that all of them are possibilities. So we'll look at some examples clearly. And all it's telling you is that these are possible zeros. Then you actually have to test them out to make sure that they really are possible, because it is possible. I feel like I'm saying possible a million times. It's possible that none of these are going to work. So that means all of the zeros are actually imaginary or irrational or a combination of the two. Okay, so this theorem is nice, really kind of used in the day when, we didn't have our fancy graphing calculators where we could take a look to see what kind of zeros we had. This theorem helped us kind of figure out and narrow down our possibilities. Okay, so let's give this a shot here. It says find all the real zeros for the following polynomial function. Okay, so it is cubic, x cubed, right? So I know that I'm going to have 3 solutions, or 3 zeros. Okay, so I'm just going to make myself a note over here. We talked about that in the intro video. And it says list all the possible rational zeros, and that's going to be this theorem that I was talking about. So I need to know what the leading coefficient is, and that's the number in front of the degree, and I have a third degree function, so my leading coefficient is 1, and the constant is 10. And then you take all the factors of your constant. Okay, so all the factors of 10 are going to be 1 and 10 and 2 and 5. So 1, 2, 5, and 10. Okay, all the factors of my leading coefficient are factors of 1. Well, that's easy, 1 and 1, right? So I don't know why I wrote 1 twice, so 1. So the possible rational zeros are plus or minus all of the factors of 10 divided by the leading coefficient, while all of these divided by 1 are just going to be obviously those numbers. So 1, 2, 5, and 10, plus or minus all of those. So I really have 4 possible rational zeros. Now it says to test these using synthetic division. Okay, what I would do also is, if this were a calculator question on an exam, is I would pick up my calculator and I would graph this cubic function, because maybe I can just kind of see on the graph if it's crossing at 1 or -1 or 2, etc., and just narrow it down there without actually having to test it. So just FYI, and I'll just kind of sketch a tiny graph down here, but it looks like this. Okay, so I do know that all 3 of my solutions are crossing the x-axis, so they're real. And it appears to me on my graphing calculator that this is -2, and it appears that that's a 1, and it appears that this is a 5. Now, if I didn't have my graphing calculator, I wouldn't be able to narrow it down, but I'm going to test x equals -2 since that's what it looks like on my calculator. So I put -2 out front and I do the synthetic division process. So 1x cubed minus 4x squared minus 7x plus 10, and I do synthetic, which you should be getting good at this point, and I get a 0 remainder. What does that tell you? If your remainder is 0, then -2 is a solution. If I didn't get a 0 remainder, then -2 would not be a solution, and I'm back to the drawing board. Okay, now one of two things. I went from a cubic down to a quadratic, right? So I really at this point could say, okay, I have 1x squared minus 6x plus 5. In fact, I'll rewrite that. And is that factorable? Well, it absolutely is factorable. X minus 3, and, but it's not x minus 3, sorry. Start over here. It factors down to x minus 5 and x minus 1. And if I solve those, where is it going to cross the x-axis? It's going to cross at 5 and 1. And that's what I had thought when I graphed it on my calculator. And sure enough, I just verified that. So do I have to use synthetic division to test all of these? Not necessarily. Could I? Yes. I could do this process and replace my -2 with a +1, and I should get a 0 remainder. I can take my 5 up there and do synthetic division, and I should get a 0 remainder. However, you can also use, your logical skills here and know that, okay, I went from cubic to quadratic, and hey, maybe that's factorable, so I can find the other two. So this theorem is really cool if you don't have your calculator, because you could just sit and test these until you find one that works. So what if you had tested 10? Well, obviously it's not crossing at 10, so if you tested 10, you would not get a 0 remainder, hence you know that that does not work. Okay, so here we go with a kind of a realistic problem. It says find all the real zeros of the function. Okay, so I have a cubic function, and let's say that this was a no calculator question, okay? So I know that it's cubic. I know I should have 3 solutions, but I don't have my calculator, so I have no idea where to start. Lucky for me, I can use the rational root theorem. So I take all the factors of my constant, so that's going to be 1, 2, 3, 4, 6, 8, 12, and 24, and I divide them all by factors of my leading coefficient. Well, lucky for me, that's 1. So all those are divided by 1, which won't change them. And then I remind myself that it's plus or minus all of those possibilities. So I really have 1, 2, 3, 4, 5, 6, 7, 8, 8 times 2, 16 possible zeros. Without my calculator, that could be a nightmare. So I'm going to tell you this. You really, without your calculator, you pick one. I mean, who knows? Maybe you're going to get lucky and pick one that works, and maybe not. Okay, so let's just say I would start with 1. Okay, now I can do synthetic division and just kind of do test 1 here. So if I lay out all of my coefficients and do the synthetic process, I can see that this is not going to work because I don't get a 0 remainder. Okay, so I know that 1 doesn't work. Now, I'm going to tell you a little shortcut hint, possibly. Instead of doing synthetic division to see if I get a 0 remainder, why don't I just do direct substitution to see if I get a 0 remainder? Because if I put 1 in here, 1 cubed is 1, plus 3 times 1 squared is 3, so 1 plus 3 is 4, minus 10 times 1, so 10. So 4 minus 10 is -6. -6 minus 24 is -30. So I would know that 1 doesn't work. If I put -1 in here, because I can do that pretty quickly in a mental manner, -1 cubed is -1 plus 3. That's going to be 2 plus 10, because I'm putting in -1. So that's going to be 2 plus 10, which is 12. 12 minus 24 is -12. So right off the bat, I know that 1 and -1 don't work. Okay, so you can, and as much as you want, I can now try to put 2 in and kind of just do the mental math. I can put 3 in and -2 and -3, etc., etc. Okay, so just to kind of give you a little hint there. So this one didn't work. So now I'm back to the drawing board, and I'm going to try, let's say I'm going to do mental math, and positive 2 does not work. 2 cubed is 8, plus 12, minus 20, minus 24. It's not going to work. But mentally, negative 2 works. So rather than sitting here and trying all of these, mentally anyway, I'm going to do the synthetic process with negative 2, because now I know mentally I tried it, and I know that it works. And if you don't want to try mentally, then do synthetic for all of them. That's fine too. And I get a 0 remainder. So that's awesome. So I know negative 2 works. I also know that I went from a cubic down to a quadratic. So I'm going to take a look at this quadratic and cross my fingers that possibly that's factorable. And good news for me is that factors down to x plus 4. And x minus 3, and could I solve those at that point? I certainly could, and that's going to be negative 4, and that's going to be positive 3, and I tested negative 2, and it worked. So I just found all 3 solutions, which all happen to be real. Please remind yourself that not all 3 would have to be real, but it just worked out that they were. So it is trial and error without your calculator. You're just trying all of these plus or minus possibilities until you get one to work. And really, once you find one that works with a cubic, you're down to a quadratic. So just solve that. Don't just keep trying these unless you really want to.